We start our story in the French Revolution. With the vanishing of royal power in France, new styles of government were established in the 1790s. Old economic and social institutions were abolished. A new spirit was abroad. Despite terror and chaos, scientists and mathematicians did what they could to lend their talents to the new republic. The revolution would lead to the end of the prestigious Royal Academy of Sciences, based in the Louvre, to be replaced by a new organization, the Institute of France. In those revolutionary years, everything seemed possible. A number of grand schemes for reform were proposed, including a scheme for reforming weights and measures so that they would be standard across the country, and preferably internationally. A commission was set up, and to it were appointed the leading mathematicians of the country, Morge, Lagrange, Laplace, Legendre, all people we'll hear more of later. And here, in the library of the Institute of France, is preserved one of the most remarkable products of those revolutionary years, the great 19-volume set of trigonometrical and logarithmic tables to decimal divisions, set up by the Commission and carried out by an engineer, Gaspard de Prony. So here, for example, in this volume of sine tables, we can see how the right angle was divided into 10,000 parts. For example, 0.0303 of a right angle in the new division is what corresponded to 2 degrees, 43 minutes, 37.2 seconds in the ancient division. And its sine is 0.04757 and so on for 29 decimal places, an unprecedented degree of accuracy. So how were these results achieved? This mammoth task was carried out by the idea of division of labour, which de Prony got from the Scottish political economist Adam Smith. Smith's The Wealth of Nations contains a description of how a pin-making factory works, and de Prony applied this to the production of these tables. He set up 3 teams. The top team, headed by the mathematician Legendre as factory manager, so to speak, drew up the analytical formulae on which the rest were calculated. The second team, who were less highly trained, converted these formulae into numbers, which were then passed to the third team, who were virtually untrained people and only had to add and subtract according to instructions they were given, and enter the results in these tables. To check the calculations, de Prony had 2 sets of teams working on the tables. The set of tables produced by one team is here. The set produced by the other team is a couple of miles away at the Paris Observatory. On the first page of these sine tables, we have a note giving instructions for the printing of the tables. It says that when they are printed, the proofs have to be checked against both sets of tables. But when de Prony finally completed his tables, they were considered too expensive to print. But they remained here in the Institute of France, available for consultation. And the division of the right angle into decimal parts was passed into law in 1799, along with the other components of the decimal system.